Let us go for the problem number 14. A circuit containing 80 millihenry inductor, 60 microfarad capacitor, which are in series and is connected to 220 volt, 50 hertz AC supply. The resistance in the circuit is negligible. Here no resistance is used, or we can say that inductor is having negligible resistance, and even the capacitor also. So what we have to find here, the first one is obtain current amplitude and RMS. We have to obtain here current amplitude I naught and current IRMS. Okay, first. Second, obtain RMS value of potential drop across each element. Now we have to find potential drop across inductor and potential drop across capacitor. These two we have to find here. And third, what is the average power absorbed by the circuit? So now let us go to analyze the given problem line by line here. First, as I said you that I would like to solve this one by a reverse engineering method. I mean to say I'm going to analyze that numerical problem. Now the third is what? What is the total average power absorbed by the circuit? So I can say third, you just see average power absorption, average power absorption must be 0. Why? Must be 0. Why means that the circuit do not contains any resistance, and we know that if it is inductor and capacitor, then power dissipation is how much? It is 0. You should remember these things. हमें पता होना चाहिए कि सर्किट के अंदर रेजिस्टेंस यूज नहीं हो रहा है, और यहाँ पे जो वर्चुअल पावर होती है इंडक्टर और कैपेसिटर के कारण से, that is going to be 0. Okay, fine sir. Second analysis now. What is the second question we have to find here? Obtain the RMS value of potential drop across each the element. I mean to say voltage across inductor, I can say, voltage across inductor is equals to IRMS into XL. V is equals to I into R form. Okay, so now I don't have the value of XL, so I can easily find XL is equals to 2 pi F into L. So now here again we don't have IRMS value master, but I have formula for IRMS is equals to VRMS by Z. So again I can say that the value of Z is don't know sir, then how I can find the value of Z means Z is equals to under root of, that is R square is 0. Okay, fine sir. XL is XL minus of XC whole square. These two circuits are there, because of that one only, R value is 0 here. Anyhow, so let us find one by one now. We will get the result. What is that means? XL is having this formula, and X is having, X is equals to 1 divided by 2 pi F into C. So in this way we get value voltage across inductor, and similarly voltage across capacitor is equals to IRMS into XC. So these are the formulas where we are looking here now in the second case. So let us take this method to a side. You have to remember these things, how to solve this. The analysis of problem is very important. Now we got the two things here, we find out third case and second case, and here first, what is that one? Obtain current amplitude and RMS value. हमें तो अभी पता करना है amplitude, that is what I naught. See first, I naught is equals to IRMS into under root of 2. So early here I have obtained IRMS value, so not need to be do anything with this one. So let us take aside. So these are the analysis. Okay, fine. So let me go for the solution of this one now one by one. Okay guys, बच्चा पढ़ी ध्यान सुनना. What are the given data? First of all, let me write here. That is, the circuit contains the inductor value is how much? 80 millihenry. Okay, fine sir. Capacitor of capacitance, that is what, 60 microfarad. Okay, fine. Then these are circuits are connected in series. Now RMS voltage is what, 220 volt, and given frequency of AC is how much, 50 hertz. Okay, fine, that resistance value is here approximately equals to 0. First, I'm going to do the calculation for the first here. Okay, what is the first calculation? It is obtain amplitude I naught. I naught. I can say I naught is equals to IRMS into root 2. So to know the IRMS, no, here you can look here. IRMS is equals to VRMS by Z. So how to first of all find the Z? In order to find the Z, XL is equals to what now? I need 2 pi f into L. So 2 pi f value is I have already calculated 314 for 50 hertz into that value of L is how much, 80 into 10 power of minus 3. So approximately I get the value of this one of 25.1 ohm. So XL value is 25.1 ओहम अपन को मिलने वाला है. चलो ठीक है सर, अभी ये तो हुआ XL. Similarly XC is equals to what? XC is equals to, I can say, 1 divided by 2 pi f c. Okay, 1 by 2 pi f की वैल्यू मेरे पास रेडीमेड है 318 इंटू 10 पावर ऑफ माइनस 6 डिवाइड बाय c का वैल्यू कितना अपन के पास 60 इंटू 10 पावर ऑफ माइनस 6. So from this one I get the xc value is around, xc value is getting around how much means 53 ohm. So दो बातें तो अपन को मिल चुकी है. ಏನು ಮಾಡಬೇಕು, ಥರ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಏನು ಇದ್ರೊಳಗೆ z ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Okay, now so how I can find the z means I know master, z is simply is equals to under root of xl minus xc whole square. If I substitute these values and calculate the further things means let me say negation. Okay, anyhow it is going to get the positive value. So 53 minus of 25.1 whole square. Now around I get z value, that is approximately I obtained 28 ohm. Roughly मुझे इसका वैल्यू आ रहा है 28 ohm z का वैल्यू. Fine. Okay sir, then what is the next? Now we got the z fine, that is what IRMS, no? So IRMS is equals to, I get VRMS by z value. So what is the value of VRMS? 220 divided by 28. So this is going to be obtained here at 8.2 amperes. Okay sir, now ಈಗ ನಮಗೆ ಏನು ಬಂತು, ಇದು IRMS ಕರೆಂಟ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀವಿ सर. ಇದು ಎಷ್ಟು ಬಂತು ಅಂದರೆ 8.2 एम्पियर इतना हमारे पास आया गया है. एंड पीक करेंट, नो वी आर लुकिंग टू फाइंड पीक करेंट. the peak current andre amplitude. So how we have to calculate that amplitude? I naught is equals to IRMS into root 2. IRMS is how much guys, 8.2 into root 2. So finally the value of peak current is around 11.5 into amperes. You can check with the calculator. Okay, so in this way I got the peak current. Okay, fine sir. Now what is the second answer we are looking here? That is what means potential difference across L and C. So first, potential drop across L is equals to, I can say, IRMS into XL. IRMS is how much we obtain here, 8.2 into XL is कितना आया है 25.1. So around I get here potential drop across that inductor is 205.8 volt. So this is voltage drop across inductor. Similarly, now voltage drop across capacitor VC is equals to IRMS into, that is XC. What is the value of XC here? Where is that value of XC? 53. So IRMS is 8.2 master into how much I said, 53. Okay, fine. Now I get that VC value is around 434.6 volt. Okay sir, so these are the voltage across capacitor and inductor we obtain here. Now similarly the average power loss, power absorption is 0. Power absorption is how much? 0, sir. Okay, anyhow, so these are the answer. See the problem number 15. A series LCR circuit of inductance 0.12 Henry and capacitor of capacitance 480 nanofarad. Resistance is 23 ohm is connected to a 230 volt, which is with a variable frequency. Okay. First is what is the source frequency for which current amplitude is maximum? So what we have to find, what is the source frequency for which current amplitude is maximum. तो हम लोग मैक्सिमम करंट कब है बोलते हैं सर्किट के अंदर, करंट मैक्सिमम कब होगा. चलो पहले हम लोग लाइन टू लाइन लेते हैं यहाँ पर सॉल्यूशन. व्हाट इज द गिवन डेटा, दैट इज राइट हियर. Inductance of this inductor is L is equals to 0.12 Henry, and capacitance of this capacitor is 480 nanofarad. Okay, and resistance of the resistor is 23 ohm, and VRMS voltage is 230 volt. Frequency is variable, delta omega I can say. Now first what we are going to find, what is the source frequency for which current amplitude is maximum. So first condition is that we are going to analyze here. हम लोग यहाँ पे analysis कर लेते हैं. यहाँ पर पूछा क्या है यार, पूछा है कि हमें source frequency पता करना है. We have to find source frequency. We have to find source frequency when we have to find that current amplitude is maximum. Amplitude is maximum. Current amplitude is maximum. I mean to say maximum current. So बताओ सर्किट में RLC में करंट मैक्सिमम कब होता है. RLC में सीरीज में AC in series gives maximum current at resonance. Gives maximum current at resonance. तो ये एनालिसिस कर रहे हैं हम लोग. ओ हो, यानी कि हमें यहाँ पे इनडायरेक्टली रेजोनेंस फ्रीक्वेंसी पूछा है. Indirectly we have to find here resonance frequency beta. So let us find first. Let me find first here resonance frequency. Resonance frequency. Okay, fine. So resonance frequency omega naught is equals to, we have a ready-made formula, 1 divided by under root of L into C. Put these values here. 1 divided by under root of, what is the value of L? 0.12 into 480 nanofarad. Okay, so I got this value here. Omega naught is around 4166.7 radian per second. So this is the source frequency at which current in the circuit is maximum. तो ये तो पहला solution हो गया. दूसरा क्या है, what is the source frequency for which average power absorbed by the circuit is maximum. What is the source frequency? Let me again repeat you one more time. See, what is the source frequency for which average power absorbed by the circuit is maximum. Okay, fine. One more frequency we have to find. One more frequency we have to find. What is the source frequency for which average power absorbed by the circuit is maximum. See guys, we know maximum power in RLC series B. In RLC series, maximum power transferred by the circuit, P0 is equals to, I can say, I0 square into R. So now I have to find I0 here. अभी यहाँ पे मुझे I0 की वैल्यू निकालनी पड़ेगी. So how I can find that I naught means I naught is equals to V naught by R, the circuit at resonance. So in place of Z I have written R. So V naught is equals to, I can say, V RMS into under root of 2, maximum voltage formula, and R is having certain value. So VRMS is 230 volt into root 2 divided by R value is 23. So I get here 14.14 ampere. This is what I naught value. So therefore maximum power transferred at this frequency by the circuit is P naught is equals to 14.14 whole square into 23, which is around equals to 4598.6 watt. So this much of power is transferred by the circuit at a resonance condition. And how much power is absorbed by the circuit? That is also very important. No, half the power at resonance. At resonance, power absorbed by the circuit. Power absorbed by the circuit is absorbed is equals to P naught by 2, half the maximum power transferred. So which is equals to 4598.6 by 2 is nearly, I got here 2299 point okay, ठीक है, approximately this much of power is absorbed by this circuit. Okay, fine sir, fine. Now let me go for the third one. What is third? I know here maximum power nikala. What is, obtain the value of this maximum power? We got the maximum power. Here is the maximum power transferred. This one is the power absorbed by the circuit at resonance. For which frequencies, here should be frequencies, for which frequencies of the source is the power transferred to the circuit half the power at resonant frequency? ऐसे कौन से frequencies को, अब क्या बोल रहा है, ऐसे कौन से frequencies, for which frequencies of the source is the power transferred to the circuit is half the power at resonance? ऐसे कौन से frequencies को maximum power transferred by the circuit is half is equals to half the, see, right now here at resonance power absorbed by the circuit is this much. तो हमें क्या मिला है? हमें मिला है यहाँ पर रेजोनेंस पे सर्किट ने कितना पावर अब्जॉर्ब किया, इतना पावर अब्जॉर्ब किया है। रेजोनेंस पे सर्किट ने कितना ट्रांसफर किया है पावर, इतना पावर ट्रांसफर किया। फिर से एक बार रिपीट कर देता हूँ, रेजोनेंस पे मैक्सिमम पावर सर्किट ने कितना ट्रांसफर किया है, 4598.6 किया है। रेजोनेंस पे मैक्सिमम पावर कितना अब्जॉर्ब किया है, 229 वाट इतना किया है। तो ये तो हुआ रेजोनेंस पे। तो हमें ऐसे फ्रीक्वेंसीज बताना है जितना रेजोनेंस पे इसने पावर अब्जॉर्ब किया है उतना उसको मैक्सिमम ट्रांसफर करना चाहिए। आई मीन टू से कि भाई ध्यान सुनना। अब थर्ड सवाल क्या है हमारा? थर्ड सवाल क्या है? फॉर विच फ्रीक्वेंसीज ऑफ द सोर्स इज द पावर ट्रांसफर्ड टू द सर्किट हाफ द पावर एट रेजोनेंस फ्रीक्वेंसी। हमें तीसरे में पूछ रहा है कि भाई हमारा सर्किट जो है आरएलसी मैक्सिमम पावर कितना ट्रांसफ़र करना चाहिए। मैक्सिमम उसको करना है 2299 जो कि रेजोनेंस पे अब्जॉर्ब कर रहा था, जितना पहले के केस में रेजोनेंस पे अब्जॉर्ब कर रहा था उतना ही उसको मैक्सिमम पावर अगर ट्रांसफ़र करना है तो फ्रीक्वेंसी चेंज करनी पड़ेगी। तो वो फ्रीक्वेंसीज क्या है? दैट इज़ द क्वेश्चन फॉर अस हियर। नाउ फर्स्ट ऑफ ऑल लेट मी फाइंड चेंज इन फ्रीक्वेंसी इन दिस केस। तो यहाँ पे मुझे सबसे पहले क्या पता करना पड़ेगा? चेंज इन फ्रीक्वेंसीज पता करना पड़ेगा मास्टर। यदि मुझे चेंज इन फ्रीक्वेंसीज पता होते हैं तो मैं इजीली यहाँ पर जो है ओमेगा 1 एंड ओमेगा 2 भी आराम से सॉल्व कर सकता हूँ। सो देयरफॉर चेंज इन फ्रीक्वेंसी, नाउ आई एम फाइंडिंग हियर change in frequency at current in the circuit is equals to maximum amplitude of current. सो फॉर दिस वन आई हैव डेल्टा ओमेगा इज इक्वल्स टू आर बाय टू एल, ये फार्मूला आपको याद रखना पड़ेगा, आर बाय टू एल विच इज इक्वल्स टू 23 divided by 2 into that is 0.12. now I got here 95.83 radian per second. So this is what change in frequency. So this much of frequency is changed during this one. maximum power पहले देखो, पहले सर्किट में मैक्सिमम पावर कितना ट्रांसफर किया था 4598, ओके रेजोनेंस पे था। और अब यदि सर्किट को हमारे मैक्सिमम पावर ही ट्रांसफर करना है 2299 वाट, तो उस केस में हमारा चेंज इन फ्रीक्वेंसी कितना रहेगा, दैट इज डी डेल्टा ओमेगा इज इक्वल्स टू 95.83 रहेगा। सो लेट अस फाइंड दैट फ्रीक्वेंसीज हियर। चलो अब फ्रीक्वेंसीज पता करते हैं। सो फ्रीक्वेंसीज एट विच पावर ट्रांसफर्ड इज हाफ, frequencies at which power transferred is half. Omega 1 is equals to, first is omega naught minus of delta omega, so this is first, which is I'm directly writing here 4070 radian per second, and omega 2 is equals to, I'm going to calculate directly it, omega naught plus delta omega, which is equals to around 4 to 6 to something. So 4 to 6 to no, it is plus, no, so 4 5 means 4 7 something I have to obtain here. Delta omega is 95, no, so 46 4 6 something I have to obtain here. Let us check here how much means 4 to 6 to radian, यहाँ पे कितना आया है, ओके 4 to 6 to रेडियन पर सेकेंड। यहाँ पे देख लो आप लोग, आपके पास ओमेगा नॉट है 4 1 omega naught. So you got these two frequencies where we are looking to find, and at this power अब मैक्सिमम करंट भी चेंज होगा ना यार। क्यों मैक्सिमम करंट चेंज होगा, क्योंकि अभी रेजोनेंस वाला कंडीशन है नहीं यार। अभी हमको रेजोनेंस तो कितने पे मिल रहा था, रेजोनेंस हमें मिल रहा था इतने मैक्सिमम पावर पे, तो हमने मैक्सिमम पावर ही ट्रांसफ़र कितना किया है, जितना हाफ पावर अब्जॉर्ब हुआ था, जितना पावर अब्जॉर्ब किया था रेजोनेंस में, हमने सर्किट की फ्रीक्वेंसी चेंज करके उतना ही मैक्सिमम पावर डिलीवर्ड कर दिया है। तो उस केस में हमारे पास जो मैक्सिमम करंट आएगा, आई डैश इज इक्वल्स टू, अगेन आई कैन राइट आई नॉट बाय रूट टू। सो आई नॉट की वैल्यू हमारे पास ऑलरेडी है 14.14 डिवाइड बाय रूट टू, विच इज इक्वल्स टू 10 एम्पियर। देख लेना अब ये जो है 10 एम्पियर। So this is what the final. So let us go for the problem number 16. I'm reading here, an alternating EMF of E is equals to 100 sine of 628t is applied to a device which offers a resistance of 10 ohm. Now calculate the RMS value and average value of the current. So let us first of all write the given, whatever the given things are available here. That is E is equals to 100 times of sine of 6 to 8 times of t. So this is the given, and we are going to compare this equation to with E is equals to E naught sine of omega t. So this is what we are comparing here. Okay, fine sir, then what is the value of E naught from this equation? I got 100 volt maximum voltage. अगर हमारे पास मैक्सिमम वोल्टेज अवेलेबल है तो मैं मैक्सिमम करंट डायरेक्टली निकाल लूँगा यहाँ से। सो देयरफॉर फर्स्ट इज व्हाट आई एम कैलकुलेटिंग हियर, पीक करंट मैं निकाल लेता हूँ यहाँ पे, मुझे तो आरएमएस चाहिए, लेकिन पीक करंट मैं यहाँ से निकाल रहा हूँ। आई नॉट इज इक्वल्स टू ई नॉट पीक वोल्टेज बाय मैक्सिमम रेजिस्टेंस। सो पीक वोल्टेज वैल्यू इज हाउ मच, इट इज़ 100 डिवाइड बाय 10, आई गॉट 10 एम्पियर ऑफ द मैक्सिमम करंट। So now here I am going to find IRMS value. So IRMS is equals to, already we know that sir, I naught by peak value by root 2. So which is equals to 10 divided by root 2, which is now 7.07 amperes. Third is what, average current। एवरेज करंट का फार्मूला भी हमारे पास रेडीमेड ऑलरेडी है। एवरेज करंट इज इक्वल्स टू दैट इज 2 डिवाइड बाय पाई इंटू पीक करंट। ये ईजी है यार, इसमें कोई दाम है नहीं उतना कि 2/3.14 into I naught is how much, means 10, no? So which is equals to, I get here approximately 6.37 ampere. Let us go for problem number 17. The equation of current is given us, that is I is equals to 4 times of sine of 100 pi times of t plus pi by 3. And now we have to find here RMS value of the current, peak value of the current, frequency of the given current, initial phase, and current at t is equals to 0. So let us find one by one here. Let us solve this one. What is given? Given is what? That is I is equals to, in the given, I is equals to 4 times of sine of 100 pi times of t plus of pi by 3. So this is the equation of current. Now I am comparing this equation of current with the standard equation. I is equals to I naught sine of omega t plus of phi. With this equation I am going to compare. First, now I am finding peak current. First I am finding peak current from 1 and 2, from equation 1 and 2, 1 and 2, the peak current is that is 4 ampere, no? I naught is equals to 4 ampere. ठीक है सर, मिल गया. What is the first one? RMS value. So I'm finding here, next is the RMS value. First, RMS current value. What is the formula for IRMS? IRMS is equals to I naught by root 2, which is equals to 4 by root 2. Now I got this one approximately here 2.83 ampere. 2.83 ampere. What is the next? What is the next one? That is what, frequency of the AC, no? Third, frequency omega, no? Omega is equals to, what is the frequency of AC? Frequency I am calculating here. Frequency omega is equals to 2 pi into f. So f is equals to, I am going to find here. Acha, omega is equals to how much here? 100 times of pi. 100 times of pi के बराबर आया है. pi से pi यहाँ पे कैंसिल हो जाएगा. So f is equals to 50 hertz. So I got the frequency of this AC. Fourth, phase, initial phase, no? Initial phase is given in the equation, that is phi is equals to pi by 3. You can check here, pi by 3. Now fifth is at t is equals to 0. At t is equals to 0, we are finding the current. So I is equals to, equation is what? 4 times of sine of 100 times of pi into t plus of pi by 3. So t is 0. T is equals to 0. Whole term becomes 0. So I is equals to 4 into sine of pi by 3. So what is the value of sine pi by 3? Approximately that is what, trigonometrically 3 root 3 by 2. Now I get here answer 3.4 ampere. That's it.